In this video, we will go over optimization problem type number 5. Here, the optimization problem is involving exponential functions. Exponential functions, we have two different types of problems, but exponential functions is easier than the rest. Why? Because we are given an equation. So our need is not to find an equation. We just have to work with the given equation. So that's why our life is easier in this case. Let's read the question first. The effectiveness of studying for an exam depends on how many hours a student studies. Some experiments show that if the effectiveness E is put on the scale of 0 to 10, then this is the equation for effectiveness of studying, where T is the number of hours spent studying for an examination. If a student has up to 30 hours for studying, how many hours are needed for maximum effectiveness? Because we have to maximize effectiveness, and we can clearly see that this is our effectiveness equation. So all we have to do is just put the effectiveness equation here because we need to solve this equation. So this is how the equation looks like. Once we see this equation, our first step is writing the equation. That is done. Second step is writing the domain. So if I want to find out what is the domain, I need to find out domain with respect to time. So I'm going to find out what is my minimum and what is my maximum time for studying for the exam. We see here that a student has up to 30 hours. So a student can study equal to 30 hours or up to 30 hours, or student cannot study at all. So this is going to be our domain. Next step is to find out the derivative of effectiveness. Now this is an exponential function equation. We all know how to find out the derivatives of the exponential function equation, and the derivative is going to be, this is 0.5 as is. If you want to multiply, you can multiply, it's up to you. So I do 0.5 times 10 plus 0.5 times t e to the power negative t over 20. And we have to find out the derivative of this entire thing. Derivative of this first part is going to be 0 because it's a constant. Then derivative of this is going to be, in order to find out derivative, we have to first see how it is going to be like. This is a product of this and this. So we would be applying product rule on it, and this is what we get. Derivative of e to the power negative t over 20 will give us e to the power negative t over 20 as is, times the derivative of negative t over 20. And this we also have, so we're going to put this there too. So finally we are left with further, and the derivative of this is going to be negative 1 over 20. I'm going to do it here. I can take this out as common. So 0.5 e to the power negative 20, I have this here, and 0.5 e to the power negative 20, I have this here as well. So I can take that out as a common. I'm left with 1 from the first factor, and I'm left with minus t over 20 from the second factor. So my derivative of effectiveness finally is 0.5 e to the power negative t over 20, 1 minus t over 20. This is my effectiveness equation. I have got my equation. My next step is to just find out my critical numbers. So I am going to sub this equal to 0. So all I'm going to do is just put this equation equal to 0. I have 0.5 e to the power negative t over 20, where I have 1 minus t over 20 equal to 0. Now this is my product of this and this. So if I put this equal to 0, 0.5 e to the power negative t over 20 equal to 0. If this is equal to 0, I would get a 0. Next is 1 minus t over 20 equal to 0. I cannot solve this side, so I'm just going to be solving this one. 1 is equal to t over 20, so time is equal to 20 hours. Now this is my critical number, and my domain limits are 0 and 30. So the three t values that I'm going to be testing is t1 equal to 0 hour, t2 equal to 20 hours, and t3 equal to 30 hours. I'm going to test all of these, and I'm going to find out my effectiveness. So when I find my effectiveness, all I have to do is just put this in my effectiveness equation. My effectiveness equation is ET equal to 0.5, and then I'm going to sub in E as 0 in here. So if I put in 0 here, I'll be left with 0, and all I'm going to be left with is 0.5 times 10 is 5 is the effectiveness. The next one is if I sub in E as 20 and I again solve this. You can use a calculator to solve this. You'll be able to get 8.7, and if you study, your E is going to be equal to 8.3. We have got three effectivenesses: 5, 8.7, 8.3. We are looking for the greatest effectiveness, and that comes when the student studies for 20 hours.